In this video, we will practice some of the prerequisite skills that you need to have in order to be successful in AP Calculus. Let's start with graphing. So we're just going to make some quick sketches based on our knowledge of parent functions. For example, for problem number 1, we know that an absolute value function, the parent function is like this. It makes a v, and it's going up 1 over 1 in both directions. However, this has a transformation that's being shifted to the left by 4. So if you have an x plus 4, that's actually a shift to the left 4. So we're just going to take this v and shift it to the left 4, so it should be like this now. Because we know the slope is 1, it should go straight from -4 through a y-intercept of +4. Alright, so there's a rough sketch of problem number 1. Problem number 2. You should have memorized that the parent function for the natural log is like this, right? It approaches the y-axis as an asymptote, but it goes like this. So this is the basic look of the parent function of y equals natural log of x. Notice it has an x-intercept right here at 1, 0. This negative sign in the front is going to be a reflection over the x-axis. So I'm just going to take this graph that we have memorized and I'm going to turn it upside down. Alright, it's still going to have an x-intercept right here, but it's going to look like this instead. Okay. We have memorized that the graph of the cosine function starts at the top of its cycle. All right, its highest value is right at 0, and then it falls like this and back to the midline, and it rises. So this is what one cycle of the cosine function looks like from 0 to 2 pi. And it has a maximum of 1 and a minimum of -1. So this 1 right here, which is the same as if you added 1 on the end like this, has the effect of shifting the entire graph up 1 unit. So, you know what, just for fun, I think I'm going to finish doing my sketch down here where it's easier for me to see. Alright, I'm just going to draw the rest of this. So here is another period of cosine. Alright, so there's 2 periods of the cosine function, but because of the +1, I'm just going to take all of this and I'm going to shift it up 1 unit. So this is what number 3 should look like. Okay, the parent function here is the quadratic y equals x squared. And we know that that would be a parabola with its vertex at 0, 0. So it would be doing something like this. Okay, a parabola. The transformations, because of the x minus 3, this is going to be shifted to the right 3, and because of the -1, this will be down 1. So we're just going to have a parabola that has a vertex at 3, -1. So this is just a rough sketch, so I'm not going to really think too much past this. I guess I will say, if we can quickly see what the x-intercepts would be, that would be helpful. And we know that for the parent function, you know, the vertex is here, but then we have values at 1, 1 and -1, 1, right? I'm talking about the parent function, which makes sense because if we do 1 squared, that is 1. Wow, that's a crazy y. So anyway, my point is, since we know that we have these specific values at 1, 1 and negative 1, 1, that would translate into having values here and here, which will allow me to know what the x-intercepts are. So if we can just quickly know that, that's something that you should have in your mind as well. All right, but the rest of this I will just sketch in a rough way. Okay, e to the negative x. First of all, the parent function obviously is y is equal to e to the x. This is an exponential function, the classic parent function. It is going to have a y-intercept of 0, 1. It has an asymptote. The x-axis is an asymptote, and it's increasing like this. All right, so this would be the parent function. By the way, we know that there is a y-intercept at 1 because imagine that x is 0, then this would be e to the 0 power, and anything to the 0 power is 1. However, if you have a negative sign next to the x like this, this is going to be a reflection over the y-axis. When you have a negative sign in the very front, that's a reflection over the x-axis. The whole thing turns upside down. But when you have that negative sign up there inside the function, it is a reflection over the y-axis. So I'm going to flip this thing around from left to right. So instead of being an increasing function, this is now going to be a decreasing function. So it's going to look something more like this. Okay, problem number 2. So the sine function. Let's talk about the parent function. For the sine function, starts at 0 and it goes up and back to the midline and down and back to the midline. So this is what one period of the sine function, would look like. All right, I'm talking about the parent function, just y is equal to sine x. So the transformations are, because of the 2, this has a vertical stretch of 2, and because of the negative sign, it's going to be reflected over the x-axis. So I'm going to redraw this so that it's taller and it's upside down. All right, so instead of going up like I normally would, I will go down. And I'm showing my vertical stretch by a factor of 2. So I'm going to go down to -2 and back to the midline, up to +2 and back to the midline. So this is what one period of this function would look like. And we could continue the pattern on the left side as well. Okay. All right, so that's it for the graphing. Section B. Find each value in exact form. No work needs to be shown, but we should be able to answer these questions pretty fast. In pre-calculus, you should have memorized all of the values on this chart. For example, off the top of your head, you should know that the tangent of pi over 3 is radical 3. I'm going to assume that you've memorized this. So if you have not memorized all of these values, you need to pause the screen right now and memorize it immediately. I'm going to run through these values sort of slowly because I have to explain to you my thought process, but you should be able to do this all in your head very quickly. So as soon as I see that I'm dealing with pi over 6, the tangent of pi over 6, so ignoring the 11 for a second, I see that the reference angle is pi over 6. So we have memorized that the tangent of pi over 6 is 1 over radical 3. So the tangent of 11 pi over 6 will also be 1 over radical 3, except it might be negative. That depends on the quadrant. So you just need to understand, and all this would be happening in your brain, if we're dealing with a reference angle of pi over 6, then over here at pi, I'm going to think of this as 6 pi over 6. And over here at 2 pi, I'm going to think of this as 12 pi over 6. So 11 pi over 6 is going to be just short of 12 pi over 6. So very quickly we know we are in the fourth quadrant. And we know that tangent is positive in the first quadrant and the third quadrant, and tangent is negative in the second quadrant and the fourth quadrant. So in the fourth quadrant, tangent is negative, so we know this is going to be negative. So I took a long time to explain that, but you should be able to do all that in about 5 seconds. Problem number 8. When you see the secant of 5 pi over 6, you should first ask yourself what is the cosine of 5 pi over 6, because secant is the reciprocal of cosine. So if you can figure out what the cosine is, we will just do the reciprocal and that will be your answer. Well, we've got this reference angle of pi over 6. We have memorized that the cosine of pi over 6 is radical 3 over 2. So the cosine of 5 pi over 6 will also be radical 3 over 2, but maybe it'll be negative. That just depends on the quadrant. So since we're dealing with a reference angle of pi over 6, I'm going to think of pi as 6 pi over 6. 5 pi over 6 is just one short of that, so we're going to be here in the second quadrant. Cosine is an x value on the unit circle, so in the second quadrant over here, cosine will be negative. We have negative x values. So this will be negative radical 3 over 2. So the secant will just be the reciprocal of this, so this will be negative 2 over radical 3. Okay, so the sine of 3 pi over 4, you see the reference angle is pi over 4. We've memorized that the sine of pi over 4 is 1 over radical 2. Or you might have been taught radical 2 over 2. That's the same thing. It's just a matter of will this be negative or not. 3 pi over 4 is going to be in the second quadrant. And in the second quadrant, because look, this is pi can be thought of as 4 pi over 4. So 3 pi over 4 is going to be before that. Sine is a y value, and y values are positive in the second quadrant. So that will be the answer right there. Find all solutions in the interval from 0 to 2 pi. So looking at problem number 10, we have the tangent of x is equal to negative radical 3. First, ask yourself what the reference angle is. Ignore the negative sign for a second. The tangent of what angle is radical 3? Hopefully, pi over 3 just popped into your head. All right, you should have memorized that the tangent of pi over 3 is radical 3. So that is the reference angle, but that is not necessarily the answer. There are 4 angles on the unit circle that have a reference angle of pi over 3. They are pi over 3 in the first quadrant, and look, over here on the left-hand side, this pi, we can think of this as 3 pi over 3, and on the right-hand side, we can think of this as 6 pi over 3. And that helps you remember that in the second quadrant, this will be 2 pi over 3. And in the third quadrant, this will be 4 pi over 3. And in the fourth quadrant, it is 5 pi over 3. So all we have to worry about is which quadrant will we be in? Well, the tangent is negative in the second quadrant and the fourth quadrant. That's why the solutions will be 2 pi over 3 and 5 pi over 3. All right, what about problem number 11? What is the reference angle here? The cosine of what is radical 3 over 2? So hopefully you were thinking pi over 6. You should have memorized that the cosine of pi over 6 is radical 3 over 2. But there are 4 angles that have a reference angle of pi over 6. There's one in every quadrant. In the first quadrant, it is pi over 6 itself. In the second quadrant, it is 5 pi over 6. In the third quadrant, it is 7 pi over 6. And in the fourth quadrant, it is 11 pi over 6. But here we have a cosine that is positive. So what are the 2 quadrants where cosine is positive? Cosine is an x value on the unit circle, and x values are positive in the first quadrant and the fourth quadrant over here to the right. That's why the solutions will be pi over 6 and 11 pi over 6. When we ask ourselves, where is cosecant of x undefined? You should start by remembering that cosecant is the reciprocal of sine. So this will be undefined when the denominator is equal to 0. So this is an indirect way of asking where is sine x equal to 0. So here's a little picture of the unit circle. All of this you should be just picturing in your mind. Sine is a y value on the unit circle. So the question is, where will the y values be 0? And the y values are 0 here and here. So this is 0 and this is pi. So that's why the solutions are 0 and pi.